Hello and welcome to yet another riveting installment of the Algebra 1 videos. Today we are going to learn about inequalities, and these are things that are not equal. So we have equations, that means equal, but when we talk about inequalities, these are things that, inequalities, these are things that are not equal, okay? So one's larger than the other. Okay, so here's what we've got. And when you have something like this, this is an equation, and the reason why, and I'm going to write that this is an equation, is because of our equal sign. Okay, and that's value there. So what we have is that we know that this side of the equation is balanced and equal to this side, and when by the properties of equality. What we do is we end up, getting a value of like x equals 3 or x equals negative 3 when we solve this, okay? But over here we have something called an inequality, okay? So this is an inequality. Quality. Okay, and what I notice is that we have this symbol here that represents that things are not equal, that one side is greater than the other, okay? And so, the rule of thumb, so I want to write this down, the rule of thumb for solving inequalities, okay, is we solve them just like equations. So solve just like equations. But our answers are a set of numbers, set or group of numbers, a set of numbers, okay, and that means like a group of numbers rather than a single number, rather than a single number, okay? So that's the idea. All right. So when we have comparing properties of equality, so you have these properties of equality where you add or subtract by the same value on both sides of an equation, or multiplying and dividing. Okay, when you do that to both sides, that's all good. Okay, but the problem is you do the same thing with inequalities, except for when you multiply or divide by a positive value, the inequality sign doesn't change. And if you multiply or divide by a negative value, then you have to change the direction of the inequality. So before we talk about that, what I want to do is talk about a little bit of notation, okay? And just kind of refresh our, review what an inequality really means, things that aren't equal. So what I know, with an inequality, I can say this, that 1, I'm just going to give you an example, 1 is less than 5, okay? And what this means is that 5 is larger than 1, okay? And we use this like little arrow symbol here to show that, but I could also show the same thing this way and say 5 is greater than 1, okay? And the way I know that is I think of either like the game Pac-Man, if you remember that game, the wah, 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 where you have the Pac-Man, and the Pac-Man eats the bigger number, okay? So it's going to chomp down on the bigger number. Now, let's say you didn't grow up in the 80s and you grew up in the 70s and you really like the movie Jaws, okay? So then you would think of a shark, okay, that would then eat the bigger number, okay, and it would swim off and, eat other little bigger numbers and such as, okay? So that's the idea. That's the notation. So you could also have, let me just say this. You could have, like, say 1 is less than or equal to 5, okay? Same thing, 5 is the larger number, but you could say that it is equal to it as well, or you could reverse that and say that 5 is greater than or equal to 1. Okay, so that's just some notation for you. Now let's go back through, and I want to talk about this fact right here on the next page. Okay, so let's talk about reversing the inequality. And when we solve inequalities, okay, and I'm just going to give you guys a couple of examples here, but let's do this. First things first, before we do anything, okay, let's think of a number line, and let's think of, here's 0. Here's the positive side of the number line, and here's the negative side of the number line, okay? When you're on this side, these numbers are big, okay? When you're on the negative side, these numbers are small, okay? So I'm about to give you guys some, something to think about here. But let's just take a look here for a second. All right, if I had this, let's say I have negative 2 is less than, say, 5, okay? And let's say I want to multiply both sides by a negative 2. So if I multiply this by a negative 2, multiply this side by a negative 2, they end up getting, negative 2 times negative 2 gives me positive 4, which is less than, and then over here, if I take 5 times negative 2, that gives me negative 10. Well, what we realize, thinking about, the number line, negative 10 is over here and 4 is over here. So we know that negative 10 is not larger than 4, okay? So what we have to do is we have to reverse the inequality symbol, okay? And so I would have to say that, in order to make this true, I would have to say that 4 is greater than negative 10, okay? So when you multiply by a negative, you have to reverse the inequality, okay? So... And the same thing works with division. Division is like the same thing as multiplication, really. And so let's just take two numbers here, and let's say that you have, negative 5 is less than 10. Okay, we agree that that's a true statement. And so, but if I were to sit here and go, okay, well, let's divide this each by negative 1 and divide by negative 1, then we get that this is going to be 5 is less than negative 10. Okay, and this is a false statement, just like how this was a false statement. Okay, but in order to make it true, all right, you have to reverse the inequality. You have to then say that 5 is greater than negative 10 in order to make that true. Okay, just like up here, how we made this one true, all right? So that's the idea. So whenever you multiply or divide by a negative number, you have to reverse the inequality sign, okay? Now, if you do the same thing, with addition or subtraction, let's just take like negative 2 is less than 5, and let's add 3 to both sides to this. Then we end up getting that, say, 1 is less than 8, okay? And that's still a true statement. So you can operate using addition or subtraction, and nothing's going to change. But let's also do this. Let's say we have the inequality like 5 is less than 10, and let's subtract 2 from each side, and we end up getting that 3 is less than 8, and that still remains true, okay? So, and I'm just making these up, but that's the idea, okay? So you can add or subtract, numbers to either side of an inequality. You don't change the inequality, but if you multiply or divide by a negative number, okay, then you have to reverse the inequality, all right? So now, let's talk about some other notation. Let's actually solve this inequality here, okay? So you have 3/4 x minus 2 is greater than or equal to 19. So what I want to do is I want to solve this inequality. So I'm going to do the properties of equality. I'm going to solve this just like I would an equation. Just if I multiply or divide by a negative number, then we have to reverse the inequality. So I'm going to add 2 to both sides. That's the first thing I'm going to do. So I get that 3/4 times x is greater than or equal to 21. Okay, now I want to, divide both sides by 3/4, but I don't really like doing that because I don't know how to do that technically, but I want to multiply rather by its reciprocal. So I'm going to multiply by 4/3. Okay, so I'm going to do 21 over 1, and I'm going to multiply this by 4/3. Now, because I multiplied by a positive number, okay, I don't have to reverse my inequality, okay? But these numbers, 3 over 3 divide out, 4 over 4 divide out. So you're just left with x is x is greater than or equal to. And what we can do here is I know that 21 divides into 3 evenly. So I'm going to do 21 over 3 is really just 7 over 1. So as a result, I get 7 times 4, which is 28. So I get that x is greater than or equal to 28. Now what I want to do is I'm going to graph this. Okay, that's kind of the easiest thing to do. Now, what I know is that the values of x are either equal to 28, so I'm going to put a point here, say that they're equal to 28, or that they are greater than. Okay, so the values that would be greater than would be 29. That would be a value that's greater than 28. We could also say 30. Okay, and in fact, we could say 28.5. We could say 29.5. And so really what we know is that all of these numbers here, any number that is larger than or equal to 28 satisfies this inequality, okay? So, what we know is that we have our inequality notation. So we could say that x is greater than or equal to 28, okay? We can show this with a graph, showing that all the values here are larger than or equal to 28. But we also have this concept of interval notation, okay? In interval notation, what I do is I kind of think of my number line and I go, okay, well, I know that I start at 28 and my solutions are anything larger than 28, and any number that's larger than 28, we keep going to the right and to the right and to the right, eventually we'll go to positive infinity. Okay. Now, because we include 28, because we have a value that is also equal to 28, I know that I need to include 28 with a bracket. So the bracket means that we include, that the bracket means that we equal 28 as well, okay? But then we show that we have, we go from 28 and we go to the right, so that goes to positive infinity, and I would put a parenthesis there, okay? And we'll kind of talk more about, interval notation. I will use all three of these simultaneously, okay? So we kind of need to know what each of those are, all right? So, all right, so let's take a look. We're, how to solve multi-step inequalities. What I want to do, guys, is I just want to, solve this inequality just like I would an equation. But just kind of use some. Now we got fractions and we got multiple steps. So the idea is we just want to isolate the x variable and go from there. So and it doesn't really matter where I go from here. But the first thing I'm going to do, I'm just going to go ahead and subtract 5/6 from both sides. Okay, minus 5/6. Okay, so as a result, on this next step. Okay, I get negative 7/12 x is greater than, and let me do this real quick. I'm going to do 4 over 1. I'm going to do this math up here. 4 over 1 minus 5 over 6. Let's get a common denominator of 6. So I'm going to multiply by 6 over 6. So I end up getting 24 over 6 minus 5/6, and that's going to give me 19/6. Okay. So 19/6. So we get that's negative 7/12 x is greater than 19/6, okay, minus 2x, all right? Now what I want to do is I'm going to then add 2x to both sides. Get all my x's on one side, get all my numbers on the other, so add 2x. So as a result, all right, and I'm going to put 19/6 here, let's do this. Let's do negative 7/12 plus 2 over 1. Get a common denominator of 12 and 12. So we get negative 7/12 plus 24/12. Negative 7 plus 24, that's going to give me 17/12. So I get positive 17/12 x, okay? And I did that because, so just to kind of ensure that I get a positive number here, because I will have to now multiply both sides by the reciprocal to solve for x. So I need to multiply both sides by 12 over 17. So multiply by 12 over 17. The 17s divide out, the 12s divide out, so we get that x is greater than. Now notice how I didn't have to change my inequality sign because I multiplied by a positive number. If this would have been negative, then we would have had to have changed this, all right? But I know this. I know that 12 over 6 is really just 2 over 1. Okay, and if I take 19 and multiply it by 2, okay, that's going to give me 38. Okay, so if I just take 19 multiply it by 2, I get 38 over 17. Now 17 is a prime number. It does not divide evenly into 38, but let's just get a decimal approximation and divide that by 17. And we're going to, also come over here and say that x is greater than, about 2.24, okay, 2.24. All right, it's kind of the idea. All right, so then I'm going to come over here, and I'm going to roughly find 2.24, and it's roughly about here. And at this point, I'm going to put an open circle, okay? And the reason why is because I don't include 38/17, or I don't include 2.24, okay? But I know that my values of x are larger than 2.24. I know that 3 is larger than 2.24, okay? I know that 4 is larger than that. I know 5 is larger. So what I do is I shade this way on my graph, okay? Now, so this is an inequality notation, okay? This is in graphical notation, but let's talk about interval notation. Okay? And for interval notation, what I'd want to say, if x is larger than that, I kind of look at my graph here and I say, all right, well, I would say that 38/17, okay, to positive infinity is where my solution set is, okay? Anything larger than that. But here's the thing. I'm going to put a parenthesis here on 38/17, okay? And the reason why is because the parenthesis, and I call it the parenthesis, means we don't include, don't include the value, all right? And same thing with infinity. Infinity is a concept. Infinity is not really an actual number. So when we have this, we have to just, say we go to infinity and it just kind of just keeps going, okay? So that's the idea. All right, so let's take a look at another one. Okay, let's solve this inequality and graph the solution set. What I want to do is, let's do this. Let's add 10 to both sides here. And so on this step, we get 4/9 x is greater than 1/3 x. Okay, that's the same thing as saying x over 3. All right, and then we've got -2. Okay, now what I'm going to do is I'm going to subtract 1/3 x from both sides. Okay, and let's kind of show that up over here. That I've got 4/9 x minus 1/3 x is greater than -2. Okay? Now what I'm going to do, I need a common denominator, so I'm going to multiply the top and bottom by 3 and 3. So I get that 4/9 x minus 3/9 x is greater than -2. Now when I combine these, I take the 4 minus 3, and that's going to give me a 1/9 x is greater than -2. Now since I've got 1/9, dividing by 1/9, I don't know how to do. I can't divide by fractions. But I know that I need to multiply by its reciprocal. So I'm going to multiply by 9 over 1. So multiply by 9 over 1. So as a result, here's what we get. Okay, the 9s divide out. We just end up getting x is greater than, and this is going to be -18. Okay, so what I want to do then is find -18. I'm going to put a hole at -18. And all my values for x are going to be larger, okay? So -16 is actually larger. Remember on a number line, further right you go, the larger you get, okay? Further left you go, the smaller you get, okay? So it's going to be all these numbers that are to the right of -18, okay? Now my solution set, if I were to sit here and actually, talk about the in interval notation, okay, this is my answer in inequality notation. This is my solution set graphically. But if we're talking about interval notation, then I would say that this goes from -18 to positive infinity. And that's it, okay? Okay, in this problem, we see that Dev built a garden where one side, the length of the garden is against this house, so he has to fence only 3 sides of the 4 sides. So let's draw a picture of that real quick. And let's draw the fence here, and we'll call this the length, or the width, and call this the length. And then it says the width of the garden is 33 feet, and the length of the garden is L. Okay, and then we have Lizette also built a garden with length L, but her garden is not against her house, and its width is 25 feet. So let's draw another one where we have the width like this, and then we have length. Okay, so I'm going to call this length L. This is length L. This is length L, and then we'll call this the width and the width. And the width, and the width, okay? And so what we know, okay, it's not against her wall, but the width is 25 feet. So Lizette's, this width is 25 feet, okay? But we don't know what the length is. And it says, for what integer values of L will Lizette's garden have more fencing than Dev's garden? So we have to talk about perimeter here. Okay, so if we talk about Dev's, all right, Dev's side, okay, what we see is we have the equation 2W plus L, okay? And then, what we have is that we want to know where Lizette is going to have a greater fencing. So I'm going to put that Lizette, all right, Lizette over here, has a greater amount of fencing. And we're going to call this 2W plus 2L, okay, because we have two of these W's, two of these widths, and two of these lengths. Now what we know is that the width of the garden for Dev is 33. Okay, I'm going to call this 33. So I've got this. I'm going to do 2 times 33 plus L is less than, and the width for Lizette is 25. So 2 times 25 plus 2L. Okay, and we want to just solve this for L. So for what integer values of L is Lizette's garden have more fencing than Dev's garden? And so then what we end up getting, okay, on the next step is 2 times 33 is 66 plus L is less than 50 plus 2L. Okay, and what I'm going to do is I'm going to subtract 50 from both sides. And so I end up getting, let me do this up here, we get that 16 plus L is less than 2L. And if I subtract an L from both sides, then I get that 16 is less than L, okay? So if the length has to be larger than 16 in order for Lizette's garden to have more perimeter, okay? So that's the idea. Okay, on the next one, what we have is, we want to be able to solve these inequalities using the distributive property. So let me So the idea, guys, is that we want to distribute just like we would in any other situation if we're solving an equation, except for we're dealing with an inequality. Okay, so let's go ahead and take a look at this next problem down here. And let me zoom way in so we can, we're going to have to write small here. But I want to distribute this 3/7 into each of these over here. So what I get is I'm going to get 3/7 times 35 over 1 times x minus 3/7 times 14 over 1. And this is less than or equal to 21 over 2 times x, and then add that, and then add 3 to that, okay? So now what I have is I have 35 divided by 7, okay? That divides out into 5 over 1, okay? Now if I take 3 times 5, that's going to give me 15x, okay? And then the other one, 14/7, 14 over 7 is 2 over 1. So then I get minus 6, and this is less than or equal to 21/2 x, and then plus 3. Now what I'm going to do is I'm going to go ahead and add the 6 to both sides and add the 6, and so we end up getting 15x is less than or equal to 21/2 x, and then plus 9. Okay. Now what I want to do is I want to move all my x's to the other side. All right. So I'm going to subtract 21/2 x from both sides. So minus 21/2 x. So as a result, okay, we're going to get this. We're going to get 15 over 1 x minus 21/2. 21/2 x. And this is going to be less than or equal to 9. All right, so when I do this, I need to get a common denominator. I'm going to multiply this by 2 over 2. So I end up getting 30/2 x minus 21/2 x. and this is less than or equal to 9. So if I take 30 halves minus 21 halves, it's going to give me 9 halves. X is less than or equal to 9. And then I'm going to multiply both sides by 2/9. So multiply by 2/9, and this is over 1. Okay, and the 9's divide out, the 2's divide out, and so we are just strictly left with x is less than or equal to, and then the 9's divide out. So you're just left with 2 over 1. Okay, so your x is less than or equal to 2. Okay, now this is in inequality notation. If I wanted to actually graph this, okay, and here's the deal. Because I am less than or equal to 2, I need to put an actual physical colored in dot there, and values that are less than 2 are going to be shaded to the left. Okay, and we go all the way this way. Now, if we wanted to do inequality notation, then what we would do is we would say that we start from negative infinity, okay, put a parenthesis, and then we go all the way to 2, but we include 2, so we need to put a bracket because we are less than or equal to. So I know it's kind of a lot of stuff, I know it's a lot of steps and all that, but it's important that we know how to do this, and we know how to do inequality notation. So we'll work on this, and we'll go from there. So thanks. We'll see you later. Bye.